sort of cover my screen. Okay, early examples of operating systems. Okay, so tell me any old operating systems that you know of, as old as you can think of. Let's see how far back we can go into. Okay, mainframe's a type of hardware. That's not an operating system. Quinn says Unix. Okay, Unix. I'll put that down. That's old, of course, is relative. How far we want to go back? What's it? MS-DOS. Adam says batch. Batch is kind of a generic term. That's not an actual operating system, I think. Microsoft Bob for OS. Don't remember that one. Okay, so let's go way back. Okay, so some of the really old operating systems. There was one called OS 360 that was on IBM mainframes in the 1970s into the 80s. IBM dominated the computer industry. There was an expression, a widespread expression, no one ever got fired for buying IBM as opposed to buying from someone else. And their OS 360 was one of the, at the time, certainly dominant in terms of number of sales, because there were lots of IBM's hardware systems using this one. That's an interesting one because it was around for so long, and there were so many copies of it, kind of dominated the whole industry for a long time, many years. It was studied very well. There's an interesting book by an author, I can't remember his first name, last name, Brooks. It's called The Mythical Man Month, and it's basically about project management in IT and other things. But I think it's in that book. He talks about, there was a study done on OS 360, and the same thing has been shown to apply to other systems. If you map over time the number of bugs found in a system, it tends to follow a curve something like this, kind of a bell curve kind of shape. So you find more and more, and then as you're fixing them as you go along, then they start to decline. You find less and less, and then it kind of tapers off. And this had actually been well known, this idea, at a certain point in time with OS 360 when they were developing it. When you are producing an operating system, you don't want to release it to the public, to your customers, if you're on the early part of this where you're getting more and more bugs, because bugs are really going to annoy your customers and you're going to spend a lot of time supporting them as opposed to fixing it. So typically what you look for is you want to be on the downslope before you release the software. You don't want to wait too long, because the sooner you get the money in, you can start paying for the development that has gone on earlier. So from a financial perspective, you want to get it as soon as possible, but you don't then want to be spending time wasting money on customer support. So the trick is to try and find a good place, and typically somewhere where I'm drawing this red X, that would be an approximate place. Quinn says, where is the dance slope? I'm not sure what the dance slope means. But this would be a typical place. So where you're on the down slope, is that what, maybe that's what you're looking for. The down slope is the downwards side. So somewhere about there, that would probably be a reasonable place where you're putting it out early enough that you can get some money in, but you don't have so many bugs left in the system that you're dealing with that rather than continuing the development. With OS 360, they actually made an error. They thought that the slope looked something like this. So they thought at about here, I'm drawing the black X, they thought things were about to taper off. So they kind of scheduled it for release, and yes, it was from IBM. So they put it out, and then they found they had many more bugs than they had realized were still in the system, and it became a bit of a disaster. took a long time before they got the system stable enough where it didn't have many bugs that were affecting users. So it had a bit of a bad reputation early on. I bring that up just to show you this idea of the curve and to understand some of the issues involved in the timing of these things. Okay, so we had OS 360. MS-DOS, DOS, Disk Operating System. This is the operating system that came out with the IBM PC, which was released in about 1982. I may be off by a year or two there, but somewhere in the early 80s. The IBM personal computer. This was quite a change from earlier models of computing where you had a mainframe computer and you had terminals, which were screens with keyboards that were used to interact with it. So you had one mainframe computer might support multiple terminals, and the mainframe computer typically was in a room. Some of them were big enough to fill a room with equipment. They were very large devices. And then you had wiring going out to the terminals. You didn't have what we call modern networking today. The terminals were hooked into a particular hardware device that was attached directly to the mainframe. The personal computer gave an individual computer to each person. So you had a small computer on each person's desk, each computer individually self-contained, as opposed to one mainframe supporting some number of users through wired terminals. That was quite a radical change, and that really launched the IT explosion that led us to personal computing in the 80s with the availability of the internet in the early 1990s. We then have global connectivity, particularly the ability to have client-server models of computing, and that led to the situation we have today now where a lot of our data is being moved between our local client devices and then servers. We talk about cloud computing, distributed processing, and other things. The MS-DOS, this was the operating system. It wasn't actually written by Microsoft. Microsoft got it from somewhere else. I won't go into that history. But that was the operating system. And it was called Disk Operating System because it was loaded from disk. The original IBM PC actually came with cassette tape drives where you had typically the operating system was on one cassette and then data you wanted to write or read was on another cassette, and everything was done sequentially, which has all sorts of issues. They fairly quickly deployed floppy disks. These were, by our standards today, relatively large. The original ones were 8.5-inch diameter pieces of plastic. They were floppy because if you picked them up, they were literally floppy. They were in a protective sleeve. They were very unreliable. They often developed mechanical faults, but they were fairly cheap. And then eventually they came out with a hard disk, which the first hard disk, I believe, in the personal computer was 10 megabytes, which by today's standards seems ridiculously small. But in those days, people said, oh, why would anybody ever need as much as 10 megabytes? We're never going to fill it because we don't have enough data. Typically, you were doing one thing at a time on that computer, and it had what today we call a command line interface where you would type characters on a line and it would respond with characters on a line. There were some very primitive block-based, character-based graphics. Nothing like the fancy graphics that we see later on with vector graphics and other things. And you were typically doing one thing at a time. So you didn't have this idea of multitasking. There was no mouse. There wasn't the ability to switch between different applications running at the same time. MS-DOS evolved eventually into Windows. I'll just put that here to save the writing. Windows, the first Microsoft graphical user interface. They did not invent that technology. I believe it originally started at Xerox. And there's an expression, WIMPs. Can anyone translate WIMPs for me? WIMPs stood for Windows Icons Mouse Pointer, and I've gone blank on what the S is. But these were the components of a graphical user interface. So you had windows, you had a portion of the screen that represented one application out of several. You had icons, things that you could click on, for example, to start an application or do something. You had a mouse as an interaction tool. You weren't restricted just to the keyboard. You could actually point to things, you could drag them around and so on. You had pointing devices like a stylus that you could touch on the screen. So these were some of the elements of the graphical user interface. Apple was one of the very early adopters of this, and for a very long time, I think, had a much, much superior user experience. The first time I ever used an Apple computer, I'd never used it before. I sat down at it. Someone showed me how to do one thing, and I kind of taught myself within about 5 minutes. It was just off and running, doing all the things that I want to do. It was an extremely intuitive thing to learn. Whereas the Windows ones, I think, were really kind of clunky and much harder. If we look at Windows, we then see an evolution over time. So we had Windows 2, 3, at some point Windows 95, named after the year, Windows 98. And then they keep changing the naming. So then we got to Windows 7, 8, 9, 10, 11, or whatever we're up to. In some cases, just kind of minor evolutions. In other cases, quite radical changes. There was a Windows 95 to 98, not so big a deal. Windows 98 to the next one, I think, was Windows Vista. That was a very big change. And then Windows Vista to Windows 7, again, another very big change. For some reason, they made big changes in the user experience, which a lot of users found very disconcerting because they spent years learning how to do something. They were quite proficient at it, and now there was a different way to do it. They didn't know what they were doing. And then let's go to Unix. So Unix, quite different from some of the other things. Unix came out of a different community. So IBM, very much corporate, commercial, for profit and proprietary. Everything was secret. Unix came out of a more academic research background, more collaborative, and things shared for free. Unix systems, particularly earlier on, tended to be command line interface rather than graphical, perhaps for a lot longer than some of the others, and tended to be more for what we might call the hobbyist, the expert, the geeks, nerds, whatever name you want to put, hackers, using that as a positive before it became a negative. So Unix was kind of the thing for the computer experts kind of behind the scenes who were very proficient at doing things, whereas some of these other developments were made for ordinary people who were not computer experts in order to allow them to do business tasks, preparing documents, doing calculations, spreadsheets, and things like that, where the ease of use, particularly the graphical stuff using the WIMPs and other things, became very important. Okay, so that's just a kind of a little taste of some early systems. Okay, so I was just mentioning Unix. Even today, we see this idea, lots of different variants of Unix and Unix derivatives, where they are open development, collaborative, community support, freely available. We have open source. We can actually see the source of the software code. You can read the code. You can modify it yourself. So Unix, very different flavor from some of the other commercial things, which are very tightly held. You can't see the source code behind Microsoft Windows, for example. That's controlled by Microsoft. They don't share that because they want competitors to take that and compete with them in terms of money. The downside for as a user is we can't see what's in it, so we don't know where the problems are. We just have to wait for them to find them and fix them. And there are problems found constantly in some of these large complex systems. Unix more collaborative and lots of derivatives. So people would kind of take a system, they'd modify it, make some changes, they might make that available. A lot of the licensing involved in the Unix world requires you to make things available. So if you take something that you've got for free and you make modifications to it, you then have to make that available for free and so on. There's a whole different business world in Unix. Which brings us to Linux. So there are lots of different variations of Unix. In fact, let's just go back to the Unix screen. So tell me any variants of Unix that you're aware of. Just give me some names. So I'll put Linux as one because we're going to that next. Okay, and the ones that you've given me so far are actually Linux derivatives. So before we get into that, let's go back to Unix. So some that I remember use HP UX from HP, AIX from Apple, Solaris, I think there's one from Sun. There is two main derivatives. One's called BSD. Can't remember what that stands for. I think it's Berkeley something department. And there's another one that I've gone blank on. Okay, so this is just a small handful, certainly by no means all of the different variants of Unix. And then Linux is the one that we're going to focus on. So let's jump to that. Okay, so we've got lots of examples in the comments: Ubuntu, Mint, Red Hat, Kali, Arch, Fedora, Canopix, don't know that one. Parrot, don't know that one. Tails, don't know that one. CentOS. Okay, so these are all variants of Linux. Can anyone tell me, where did Linux come from? Where did Linux start? Okay, Dean has the answer I'm looking for. So a guy named Linus Torvald, who is, I think I'm going to say Swedish, I believe he's Scandinavian, I can't remember what country he's from now, took Unix, made some changes to it, took the Unix idea, but he basically wrote his own kernel, I believe in C. So he wrote the Linux kernel, which is the heart of the operating system. And today, if you're using the Linux kernel, then it's Linux. If you're using something else, then it's not Linux. So he developed this. He made it freely available. Dean says he's Finnish. Okay, so he's from Finland. That makes sense. I couldn't remember. Thanks. So he developed this. Linux comes from his name, Linus. If you just kind of make a small modification and mix that with Unix. So Linus and Unix gives us Linux. And he made this freely available. So people could take this, the source code was available, and people have then taken that and modified it to make their own variant. And then people take a variant and they modify that. So you've got this whole kind of family tree of Linux systems. Some of the high-level variants are Red Hat Linux and Debian Linux. So those are two of the kind of early variants, and they are quite different from each other. We're going to talk about this a lot as we go along. Variants deriving from those, Ubuntu is derived from Debian. Fedora is derived from Red Hat. CentOS, I can't remember which one of those. some of those other ones, like Mint, Arch, I've heard of those. I know of them. Don't remember what their family origin is. But today, Linux systems typically are descended from either Red Hat or Debian. And different variants are designed to meet different needs. Some are designed to have better graphics. Some are designed to be small, so they run on smaller systems. A friend of mine who's quite an expert in these things says Debian is for experts and Ubuntu is for kind of everyday consumers, people who are not experts. So Ubuntu by designed to be more user-friendly, easier to use, whereas Debian designed to be a bit more sophisticated to allow expert users to do some more complicated things. Some of the features that we find in Linux are a command line interface and a graphical user interface. Unlike some other systems, for example, in Windows, there is a Windows command prompt where you can actually go in and issue commands, but that is extremely rarely used. I hardly ever use that. I wouldn't, on average, use that maybe once a month, perhaps even less. Most of the things that I want to do in Windows, I do through the graphical user interface. I'm using the mouse and I'm interacting with graphical, click and drag, that type of thing. A command line interface where you go and actually type characters on the keyboard and the response is characters coming back in a line-by-line interface is much more commonly used in Linux, in my experience, than it is in things like Windows or the Apple operating system, Mac OS. So Linux, having come from Unix, I think has held on to some of this kind of hobbyist or expert or geek kind of method. So there are some people who just simply prefer to work in a command line interface. One of the things that's characteristic of Linux is that there are multiple different graphical, let's call them toolkits, that are not compatible with each other. And in some ways that's good. It gives a variety. They have different strengths and weaknesses. In other ways, it's not terribly helpful because some of these things are incompatible. And so there's all sorts of different graphical environments, and then there are different ways of doing things within those. And a lot of times the graphical user interface actually sits on top of a command line interface. So if there's a way of doing something on the command line, people then build a graphical thing that sits on top of that that essentially issues the commands under the covers, which is a neat way to do it. It's better than reinventing the wheel and writing a graphical way to do something that's already been done. It also means that if you know the command line interface way to do it, you can choose to do that as an alternative. And some people simply like to do that. In this course, we're actually going to be doing a lot of work on the command line. And the reason for that is the command line interface is common to all systems. If you learn the way to do it on the command line, you can do it in any system regardless of what graphical interface it has. You can use a graphical tool that sits on top of it, and particularly if you understand the command line, you will understand what the graphical tool is using. But we're going to focus a lot in this course on the command line interface. And in many cases, the commands are the same, regardless of whether your particular variant derives from Red Hat or Debian. I'll point out the differences between those two. So there'll be several cases where I'll say in Red Hat they do it like this, in Debian they do it like that. But in many cases, it's the same because it goes all the way back to the command line interface, often hooks pretty closely into the kernel. So we're going to be learning how to do things on the command line, understanding how it works and what the options are, so that you'll become quite proficient. And once you are proficient using the command line, you can do things fairly quickly instead of fumbling around with a graphical user interface or being strained by the way that the graphical thing makes you do things. You can actually do things very quickly on the command line if you've memorized how to do that. Cool. Is the CLI language would be the same with different distributions? Yes. It all goes back to the kernel. So the command line interface typically hooks in, for a lot of things we're doing, goes back to the kernel, which is common to all of these variants. There are some things which are distribution specific, but those are kind of the exceptions. Okay, so that gives you a taste of what we're going to be doing. Finally, let's talk about modern operating systems, things that we use today. So I'm going to put Linux in there as one. We've already talked about that. I'll put Windows. I mentioned that one earlier. And I mentioned Mac OS. How do I spell that? Lowercase a c. Spell it like that. Gulam says Microsoft 95. I wouldn't call that modern. Let's call modern things that we're using today. I don't think anyone should be using Windows 95 today. What are other operating systems that we are using today? Okay, Gulam says he was joking. Okay, we didn't know you were joking. You might have to put that on the line. What are some other operating systems that are in use? Then there's Android. Good. Okay, so Android for non-Apple cell phones, smartphones. If you've got an Apple phone, then you're using iOS, which is small I. Okay, so those two would be for smartphones, which are quite a different environment from something like a laptop, the way that it's being used and the way that the user interacts with it. Raspberry Pi. Raspberry Pi is a type of hardware, and the operating system for Raspberry Pi is, there are several different Linux derivatives. There's one called Raspbian, which is Raspberry Pi Debian derivative. What's the other one people run on Raspberry Pi? Can't think of it. Okay, so that is actually a Linux derivative of a derivative of a derivative of Linux. Are there any other major operating systems that we should talk about here? Okay, so let's briefly characterize these. Your Android actually comes from Linux as well, that's true. Don't know the heritage of iOS. Okay, so Linux. Why do people use Linux? What is it about Linux that would choose you to use Linux over one of these others? Okay, Dean has the most important answer. I like to say 99% of life's questions, the answer starts with money. So money is a good starting point. Linux, not all variants are free. Some of the distributions you pay for. Some of them you can get them for free, or you can pay for support. So if you have an issue, you can actually get, you can call someone who'll actually help you if you've paid for it. But Linux is generally used because it is free. Some of these other ones you pay by the copy, and they'd be quite expensive. Windows costs, I don't know what it costs these days, typically some hundreds of dollars. So if you were trying to set up a server farm with 100 servers and you had to pay $200 or $300 per server for operating system licenses, that's going to get fairly expensive. Quinn says it's open source. Yes, most of these variants, you can actually get the source code. So if you want to, you can see that. Now, I think most users, that's important to some people, but probably not a majority. Some people want to see the source. Some of them want to get it and modify it to make particular modifications, but I think that's probably a fairly small exception. Gulam says a majority of companies utilize Linux. I am going to challenge you to provide evidence for that, Gulam. I'm not sure that's true. So if you can show me an authoritative source on that, I'd be very interested. But in my experience, a majority of companies are not using Linux, or perhaps they're using some Linux, but in terms of the majority of computers out there, the market share of Linux, I think, is much less than Windows and Mac OS. Vince says more secure than the others. That's probably a subjective analysis unless you've got some data that you can show us. Part of that question, if we look at the number of incidents or number of targeted attacks or something like that, it's simply the number of devices. So if the majority of users are using, let's say, Windows, then you're likely to see the majority of attacks on that because it's the most beneficial for the attacker. So wouldn't necessarily say it's more secure, perhaps has fewer security incidents, might be something we could say. Linux, Guillaume says Linux can be customized based on the need of the company. It can, but I think that's probably unusual. As I said earlier, most people are not modifying the source or going into unique customizations. Most people are probably using it the way that many others are using it. Dean says runs with fewer resources. I'm not sure about that. I just don't have enough to know about that. Adam says open source, don't you have to pay to get the latest update? It depends on the distribution. Some are totally free, some are pretty much not. So some of them are open source, some of them are not. I think if they're open source, then they stay open source, typically is the model. Guillaume says Ford works at a data center. I presume that goes back to the previous comment about customizing. Okay, so some organizations may be customizing it, but I would say in most cases, possibly not. Adam says, can I get referral? I don't understand. Adam, can you explain what you mean by that? Can I get referral? Is that in reference to the open source thing earlier? Okay, Adam says disregard. Okay, so the attraction of Linux generally seems to be reliable, seems to be reasonably efficient, and the big attraction, not so much the open source, most users probably don't care that much about that, but certainly the cost for the ones that are freely available costs nothing. So you can do the things that you need to do and not pay for it is an advantage. Windows is proprietary. You certainly have to pay for it. You have to buy the copy, even if you virtualize it. So their licensing is fairly strict, very widely used. Last I looked, they had the largest proportion of the market share. It's kind of one of those things. Once a company typically doesn't want to have multiple things that they need to support, so a company will say we're going to use all the computers in the company are going to be using Microsoft Windows. Huge organization behind it, Microsoft. We see a lot of issues with Windows over time, in part because so many people are using it that makes it an attractive target for attacks. Windows is a very complex operating system. There's probably hundreds of millions or billions of lines of code go into an entire Windows installation. And with something that big and complex, there's going to be issues. No one writes perfect software all the time. So we do see constant updates, patching of things in order to address security issues and others. But the fact that Windows is so widespread is kind of self-fulfilling. That means more people tend to follow that trend a lot. Mac OS, again, proprietary for Macintosh computers. You're kind of locked in. It's, in my experience, very unusual someone has a Macintosh computer and on that hardware they're not running Mac OS. Less so with other non-Apple computers. So people will sometimes get a laptop. It typically often comes with Windows installed. Sometimes people will overwrite that to install Linux. Sometimes they'll set up a dual partition system or something like that where they've got both where you can change from one to the other. But I find that in the Mac environment, people tend to just stay with the Mac OS. Android and iOS for smartphones, iOS if you've got an iPhone, Android if it's not an iPhone. It's a fairly simple distinction. Again, even more so than with computers, I think people tend not to change the operating system on their phone. In part, a lot of the phone companies really try to lock you in, so you can't change things, you can't add things they don't approve, you can't take your phone to a different vendor is one of the things that often happens. So people tend not, in my experience, to customize the operating system on their phone. They tend to add apps in order to do different things, but not actually mess with the operating system. It is possible to do it. If people who are experts know what they're doing. One of the problems is, if you do something that messes your phone up, then you can't do anything. All those apps that you rely on for your phone calls, your text messages, and all the other things that you do on your phone, you really don't want your phone to be hosed. So I think most people don't kind of experiment with things on their phone because they want to bust it. Raspberry Pi is an interesting platform. Was designed from the start to be extremely low cost. The first Raspberry Pi, it's essentially a complete computer in terms of the CPU, the RAM, the networking, and I/O hooks that you can connect peripherals to. So it doesn't come with the keyboard, the screen, the mouse, and everything else. But for embedded systems where you're making this part of some other device, originally started at a cost about, in my experience, I can remember the Model 3s going for about $35 as opposed to, a whole computer, like a laptop costing more like $500 or $1,000. So they were designed to be hobbyist, became popular for embedded systems. They came out with a version called Raspberry Pi Zero, which started at $5, and with networking, with Wi-Fi added, cost $10. So I mean, $10 really trivial amount. Yeah, it depends. There's now, so the Zeros, I don't know what they cost these days. They were $10 a couple of years back, and then they started adding more and more things on, so they're probably more like $30. And the more substantial ones is now with multi-core CPU. The Model 4s are up towards more like $100, but they're extremely competitive, even compared with the cost of standalone CPU chips you could put into another computer. So that's a whole different market segment. You wouldn't be running your business on Raspberry Pi for things like desktop work, the kind of things you do on a typical laptop. But for other applications, that's a really, and one of the things it was developed for was for education. So if you've got a school and you're trying to put 40 students in a class, trying to get them some hands-on experience, you can't afford to buy 40 laptops, but you can probably afford to spend 40 times, $10 or $20 on some small units if you've got a way then to allow people to get into them. All right, that's probably enough on that, and that was the last slide I had. If anyone has any questions about the lecture, please go ahead and type them. And here, I had a note earlier that's disappeared. I wanted to talk about Apple Silicon, just to make this clear. I do have an announcement in Blackboard, but particularly if you joined this, if you registered after that announcement was posted, you may not have seen that. For this class, we are going to be using virtualization, and we're going to be using, write this so you know what I'm talking about, and we're going to be using VMware Workstation. We'll talk more about that next time. And all of the systems we're going to virtualize are going to be using the platform commonly known as x86-64. This is the Intel or AMD style CPU that you find on typical non-Mac laptops, desktop servers, and so on. As of today, you can only virtualize the same type of CPU as the computer on which you are running the virtualization software. So in order to virtualize an x86-64 CPU, you have to have an x86-64 CPU in your actual computer. If you are running ordinary Windows, you almost certainly have this. If you are running Linux, you most probably have this. If you are running a Mac and it is 5 years old or more, then you may have this type of CPU. If you have a more modern Mac M1 or later, they use what they sometimes call Apple Silicon. This is an ARM-based CPU, ARM, which is a different architecture, and it does not support all the things that we are going to be doing. So if you've got a modern Mac, you can run VMware Workstation, but you can only virtualize ARM-based CPUs, which is not what we are using, so that will not be any good for you. There is the VMware Workstation product is installed in some of the Mason labs. I don't know if it's at the SciTech campus. There is a lab there, and it's only open weekdays until 8 p.m. The open lab, I think it's KJH 250 is the room. I haven't checked yet. I will check that next week. I know it's installed on some of the labs in the engineering building on the Fairfax campus. But some of those labs are used for for classes at certain times during the day. So you may not be able to get there because there's a class in there. I don't know about days, hours on that. I haven't checked that yet. But there is access. At some point, there are days and times where you can get access to that. Okay, let's go through some of the comments. Quinn says, what about Mac OS? Quinn, could you expand on that question? I'm not sure if that was to do with the previous slide or to do with this one. Oh, for the modern example, what's significant about Mac OS? Mac OS is, I believe it's derived from Linux, but very highly customized and proprietary, and it is for Macintosh computers. I presume you could run some other operating system on a Macintosh computer, but Mac OS and Mac computers are fairly tightly tied together. Okay, Gulam says Pro. Yes, it's VMware Workstation Pro is the name. It's the latest version of the VMware Workstation product. John says, do you care if you use VirtualBox or are there VMware specific terms? It has to be VMware Workstation. VirtualBox is a similar product from Microsoft. It is not freely available. Microsoft does not license it to the university, or it's not free to us anyway. So number one, you can't get it for free where you can get VMware. We have a licensing arrangement for students to get that on I think it's a semester license. It's a 6-month license. The second thing is the networking is very different between the two products. They're not compatible with each other. And the third thing is I only have access to VMware. I don't have VirtualBox. So for this course, we're using VMware Workstation Pro. We are not using VirtualBox. Gulam says, does it matter if we have the 16 version versus the 17 version? Probably not, but you can get the latest version for free as a student. I'll give information on that over the coming days. I'm not aware of any difference between the versions, and I'll be using the latest version. Typically, the latest version can use images from an earlier version, but not necessarily vice versa. But I would recommend get the latest version. John says, if you have a Mac, you could potentially use Docker to make some Linux environments. That is true, but that will not work for this course. For the assignments, I need you to do it in VMware Workstation because I have to be able to run what you run, and I don't have a Mac in order to do that. Gilbert says, out of curiosity, will VMware Fusion work? So Fusion is the Mac equivalent to VMware Workstation. I think I said the Workstation was available on both. Different product name, but Fusion is essentially the same thing for a Mac. The problem is you can only virtualize the same CPU. So if you're running a Mac that is ARM-based CPU and you run Fusion, you can only run ARM-based systems. And we are not using any ARM-based systems in this course. The ones that you need to run for assignments are x86-64 architecture. So also there are there's an application called Parallels, which allows you to run, for example, you could run a Windows instance underneath a macOS implementation. The issue is not the operating system, the issue is the CPU. So Parallels and some things are not relevant. You need to be able to run an x86-64 CPU virtualized, which means you need to have that as the hardware. Quinn says, well, I have a video on how to use VMware Workstation, how to learn it. It is very straightforward. I will demonstrate it once I get the information to you, give you guys a chance. We'll do that over the next couple of weeks. Next lecture, we're going to talk about what virtualization is and how it works, and then we'll get you started in it. It's really easy to use. Okay, so the big issue here is if you have a modern Mac, you need to get access to a non-Mac, non-Apple Silicon computer. So you need to either go to the labs, which you may have restricted days and hours. I don't know if they have 24-hour access. I don't know about after hours or weekends. We'll have to look at that. I'll check that information. You can borrow someone else's computer, as long as if they're a student, you need to be extremely careful that what you're doing is not, they don't see it, you don't see theirs. So if it was another student in this course, you would have to be extremely careful not to share work. But if you've got someone else who's got a Windows-based computer or something like that that you could borrow, that would work. The one thing you will need is a lot of RAM. I'll just write that here. So an old Windows computer, if someone's got an old laptop lying around and the thing is 5 or 10 years old, it probably won't have enough RAM. You need a lot of RAM. I would say that absolute minimum 8 gigabytes, preferably more like 32, because you need to run multiple VMs at once. And in order to do that, much memory means you probably can't run almost anything else at all on the computer. $32 gig is a reasonable amount of RAM for a modern computer. Adam, you seem surprised by that. You think that's not enough or too much? Alarm says, which section should we watch from the videos before coming to the next lecture? I will post that in the discussion board. Each week for the discussion board, when I post the message, so when I post the lecture 2 message, I'll tell you what you need to read or watch for the lecture. Adam says, currently have 16. 16 is fine. I think 8 is the minimum I'd recommend. 16 is probably okay. More is always better. Do they have to spin up at the same time? Yes, you'll be running in some case you'll be running 2 at the same time, perhaps even 3. If we need to run more than that, we can kind of stop one and start another, but you need to be able to run multiples, and they take often 2 or 3 gigabytes each. Certainly anything less than 8 probably is not going to work at all. 8 would probably be the bare minimum. And if you have 8 or 16, I would recommend close all other applications. Otherwise, you may end up in a page fault thing where the system's going to run extremely slowly. So if you are in the habit of having lots of applications open, close all of them. And I would recommend especially reboot the computer before you start running the virtualization software. I found with VMware Workstation on my old laptop, it would work fine for a time, and then something would stop working, and then a reboot would fix it. There seems to be some application that stops VMware's networking from working correctly. I don't know that it's VMware. I think it may be something else interfering with it. But the best thing to do, reboot the system, and then only run VMware Workstation and whatever else you need to do to the assignment, but don't also run your browser with 50 tabs open and have your game in the background and Microsoft Word and all sorts of other stuff. The minimum applications running, the better. Okay, I am about to post assignment to Blackboard, so I will post an announcement when that is ready. It's not there at the moment. I had an issue getting that for today, but I'll announce that. And that is all I had for today. Any other questions before we leave? Thank you, everyone, for joining me in real time. Please do that whenever you can. Even if you can only come for part of the session, then watch the rest of it on the recording. Okay, I'm seeing no questions. Okay, thank you, everyone, and I'll see you next Tuesday.